Hello, everyone. Welcome to Professor Messer's live A+ study group for the month of February. This is a study group that we do every month. What I like to do is take your questions, and I usually will send you emails out. If you're on my A+ study group mailing list, you got an email from me earlier in the week saying, hey, I need some questions, help me out. And you guys are great. You send me a lot of information that you want to know about. And I also take questions for people who are signing up there, and I take questions that I get on my website throughout the month and questions I get in my email. And so all of that works out very nicely. If you would like to watch us live, you can see our calendar at professormesser.com/calendar. And if you'd like to see what's happening live, you can always go in and see us happening live at professormesser.com/live. So it gives you a few opportunities to go in and watch what's going on and participate, because I've got chat rooms there. I've opened chat rooms on my website. If you go to professormesser.com, there is a chat right there in live at the bottom of the screen called the Live A+ Study Group. And Amy's asking questions here. Yes, put questions there. Absolutely. I've got the chat room that's on Ustream that's also in front of me, so I'm watching that as well. So I want to give you more ways to get in front of this. And as we go along, ask questions. And if you think of something, throw something in there. And if it's something I can get through, we will absolutely be able to do that. Well, this particular study group for February is one where I got some pretty good questions. But before we get going, I want to tell you that I really appreciate what you have done over the last number of months by helping out the website and effectively sponsoring this A+ study group. At one point, I was thinking maybe I'll just do this A+ study group just for people that purchase the A+ course. But then I realized we can all take advantage of this, but it doesn't stop me from thanking those people who have purchased this. For those of you familiar with what we do on Professor Messer, I make every video and put it out for you to watch online absolutely free. Every single video I make is out there for you to see. There's nothing I hold back. There's nothing secret. There's nothing in a special members area that only members might have access to. All of the videos I do are something that you can watch on professormesser.com. But occasionally, people might want to take these videos with them somewhere else. They might want MP3 versions. They might want to put that on their iPod or listen to it in their car. They might want versions they can put on their iPad or their Kindle Fire or their other Android device and be able to watch them wherever they might be, even if they aren't connected to the internet. And in those cases, you can purchase an A+ training course video set that has the audio, has the PDFs of all the slides, has the video in a low resolution and a high definition version. You can really use that for almost anything. So really nice to have that there. If you'd like to know more about where you could get a copy of that, you can find that at professormesser.com/download-A+. So it comes in kind of handy. And I appreciate those of you who have taken the time and invested in that course to help you. When you do that, you can download them immediately from the website. I send you a physical DVD-ROM when you do that as well, so you can have a piece of media to take along with you. There's no DRM on that. You can absolutely put it on all of your devices, so you can cover the bases. You can watch it and use it wherever it might happen to be. So I appreciate you helping me out with that and sponsoring that piece. For those of you that haven't been on one of these study groups before, there is also credits you can get from this. Now, if you already have your A+ certification, you can, of course, sign up with CompTIA to provide continuing education units every month. And when you do that, you can effectively keep all of these credits and earn them over time, and then 3 years go by, and at that 3-year point where normally you would have to either lose your certification or take the test again, you don't have to do either one of those. You have enough credits now, and you could just renew. You don't even have to take any more tests. You don't have to do anything special. You will continue to have your certification, and you can do that by using continuing education units. And this particular webinar video cast live stream thing is one that gives you those credits. So if you, one CEU is available for each hour spent in a relevant session. So you've got an opportunity here to earn that particular unit. All you have to do is document it and submit it to CompTIA, and boom, you got an hour of CEUs just by sitting here and hanging out with all of us. So that comes in handy as well. The thing that I find interesting, though, about this, let's just talk about CEUs for a moment, because I get a lot of questions about this. You do, every 3 years, have to renew, Steve in the chat room, to get your certification or continue to have your certification. So some people say, well, I'll just take the test every 3 years, but that's a lot to have to take the test every 3 years. The issue is one where continuing education units, they're relatively easy to get, but you have to document that and you have to register and you have to send that in to CompTIA. So that's an important thing too. It's not a lot of money every year to keep up these continuing educations, to participate in that. It's a lot more money to take your exam every 3 years. But another thing you should know, and it's important that you go out, if you have your A+, it's important to go out and read the renewal form. Search for CompTIA A+ renewal. You'll get a PDF in your Google search. If you take an exam that is a higher level exam, your older or your lower level exam automatically renews. So if you take your Network Plus and you pass it, you immediately now have renewed effectively your A+. So now everything's on a 3-year timer. So if 2 years have gone by on your A+, you take a Network Plus, boom, you've just renewed the A+. You don't even have to think about it for another 3 years. So that's really useful to have that there. And it doesn't even necessarily have to be a CompTIA exam. What if you've taken your A+, your Network Plus, your Security Plus? There are third-party exams that you can pass, and when you get those certifications, CompTIA gives you credit for renewing all of your CompTIA certifications. So you can take a Cisco exam, a Microsoft exam. There's a few others you can take that also renew these certifications. So something you should look at. A list of all of those can be found on the CompTIA website. Search for A+ renewal or certification renewal. There's a PDF that lists out all of the things that you need to know for renewing your certifications. So let's now get to your questions. Every month I get a lot of questions. This month, about the same thing. We get an excessively large number this month of questions that come through. And I always like to take my favorite question and put it first. So this time, I think this particular question was submitted via Facebook, and it was from Fred. And Fred just said, cold beer. I asked the question, what question would you like to have answered on our A+ study group? His question to me was cold beer. Not really a question, but I thought it was good enough to put on the study group. So that's kind of useful, I think. Now, I don't have an answer for him regarding cold beer. It's a little early in the day. Well, not so bad. 1 o'clock in the afternoon, Eastern time here in Florida. But I think Fred was on the right track. Perhaps I will study more about this question tonight, and I'll be glad to get back with Fred on what I find out regarding his inquiry. Now let's begin with some the questions that I got this month. One of the ones that came in very early on, I put this one away just to see, to pull this out later. This is from Godwin, who asked, what are the basic things to know about the chipsets on the motherboard? Now, this is a question. There's an entire section of this in your A+ exam requirements, these chipsets. And if you think about it, as human beings, the idea of looking at chips and trying to figure out what's inside of those and what they're doing is a little bit difficult. It's certainly not a very human thing to try to figure out. So what I've tried to do in our study materials is lay it out very logically about the architecture of a computer and why these chipsets are there and all these buses, and then also show how that looks in an actual case. So you should be able to, if you have a motherboard in front of you, or if you start looking at, grab a picture of a motherboard even. You can find some really nice high-resolution pictures of motherboards. Go to your Google image search, search for motherboards, and click the button that says, show me the big ones, show me the larger size. And you can even specify up the very, very high multi-megapixel pictures of these motherboards. And this will be useful to you later, and I'm going to show you why in just a moment. It'll be very useful to look at. So if you've looked at our materials before on our videos, then you've probably seen this picture before. You can see that you've got here a lot of different things going on. This is a very structural layout of how you might look at a motherboard. Think of this as a Google Maps photo from above of how the motherboard's laid out. And we're going to even show you more of that in just a moment. But each one of the major components of your computer that you can see are connected to each other, and there are some very significant chipsets that connect these. Now, these chipsets may or not be in your particular motherboard. Not every motherboard has every single one of these chipsets in it, but it is very useful to know the idea and the structure behind it. And there is a method to this madness. The CPU we all know about. We understand CPUs. We know that's the chip, that's the brain of your computer. There are other CPUs inside of your computer. We don't often think of them as the primary CPU. We often think of your computer as having one big CPU, but there are other microprocessors inside of your computer that are working very, very hard, in some cases harder than your actual CPU might be in particular situations. We usually separate these out into two different categories of these primary chipsets that are in your computer. And then they may be called something a little bit different these days, but we still refer to them this way in the industry. We have the North Bridge and we have the South Bridge. And that's one of the things that is the first major difference, the first major separation point inside of your computer. Now, it doesn't mean that one is sitting higher than the other. It doesn't mean that one has different priorities than the other. There's no polar opposites here. We just call them the North Bridge and the South Bridge as a way to designate what they're doing. The North Bridge, however, is generally a much more powerful chip. It's usually a much busier chip, and it's doing some pretty important things inside of your computer. Look at what it's connected to. It's connected to perhaps a graphics adapter, and it's connected perhaps to a memory, and it's connected to your CPU through something called the Frontside bus. If you've ever looked at a computer specification, one of the things you'll see on there is the speed of the FSB. And the reason that's such an important thing is because that's how fast we can transfer data between our North Bridge, or our what we call our memory controller hub, and the CPU itself. Of all the buses inside of your computer, that conversation between the memory bus and the Frontside bus through your North Bridge is probably the most busy part of what's happening inside of your PC. So if we look at that, we know that that's really has to be the fastest thing on here. And that's why when you're looking for a new computer, they promote that speed. Oh, our FSB runs this fast. Oh, yeah, but this FSB runs even faster. And if you were trying to maximize the throughput, the efficiency, and the speed of a computer, that FSB then is going to be a pretty important piece of information to know. That's an important metric of how fast this data is going inside of your computer. Now, there's many other things inside of your computer that deal with the total overall speed, but obviously you can see that's a pretty important one, because most of the time your CPU is pulling information from memory, it's calculating some information, it's putting information back into memory. It's doing this constantly. It is things like DMA, direct memory access, that allows the different systems to send data into your CPU without taking up extra cycles of the CPU, just so we can speed things up. There's a lot going on here with the memory transfer, and that North Bridge is one that is doing a ton of work. And because of that, if you look at a computer motherboard, you will very often see on the North Bridge, there's a heatsink. We've stuck a piece of metal with fins right on top of that chip because it gets so hot, we need to cool it off and see what's going on. And there are a number of utilities you can get to look at what's happening there. Now, the North Bridge is great to have that Frontside bus. And the question in the chat room from the Ustream chat room from RGPG, what about, is there a backside bus? Is there a second bus? And there is. We don't call it a backside bus, but it's the separate bus going to the South Bridge, your internal bus, or the primary connection between everything else and the North Bridge. So you can think of that as the backside bus of what's going on. We don't often even consider the speed of that because we almost always know that it's going to be a lot slower because it doesn't need to be as fast. And by making it a little bit slower, we can reduce the costs involved in producing the motherboard. And that's the idea. We want to get the cost down to a point where it's competitive and we can sell it, but we don't want to put additional costs in there that aren't even going to be used, because you can see connected to the South Bridge, it has perhaps a graphics controller, a video card that might be embedded on the motherboard. Your PCI adapter slots are here, your BIOS, ROM, and your serial ports, parallel ports, floppy drives, keyboards, the mouse. These are things that aren't putting out a ton of throughput. Not a lot. Now, your PCI adapter slots might, and so you can obviously see a lot of things might be connected to this, including your hard drives. It's still a very important chipset to have in your computer. And the question was asked in the chat room, well, does it have a heatsink? A+ King asked, does it have a cheap heatsink on it? It usually will not, from the ones that I've seen, but there's no reason why you couldn't have one there. So you will see occasionally on very high-end server type systems, they will have heat sinks on there, if only for efficiency, because there's an extra cost involved in sticking a heatsink. But if you're running a server farm, it's your database server, it's your web server, everything's happening with that. I really want that to stay cool. So it indeed might, especially if it's one where there's a lot of disk I/O, there's a lot of I/O to certain types of adapter slots. And I/O, I mean input-output. There's a lot of information going in and out of those devices. So it becomes really, really useful to have that. But there's your major separation then. You've got the really fast things generally going into a north bridge. You've got the slower, relatively slower things going into the south bridge, but it doesn't have to be exactly this way. You don't have to memorize this exact picture to know what you need to know for your A+ exam, because very often some of these components may be plugged into one thing or the other. This is not a written in stone standard. This is just a particular example based on a motherboard that I happen to have in my lab. So your motherboard might be a little bit different. You'll probably have PCI Express slots. Those might indeed plug directly into the north bridge, or they might plug into the south bridge. It depends on the architecture of your computer. If you were to look at the motherboard then, I think this is a pretty good example, we can almost see the connection here. And if you look at your motherboard, this is one of those things where you can almost view this. So I know my CPUs are up here. Happens to be a motherboard that's designed for a server environment. So it has two places to put CPUs in there. There's my CPUs, and there's my memory. Now, what sits between our CPUs and our memory? Our north bridge. And if you look at this picture, right in the middle of this screen is this big old chip. That chipset is the north bridge. There it is, right there on the motherboard. Now I'm starting to get the idea that this really is laid out just like a city. You want these things to be as close as possible. It doesn't make sense to put your north bridge way down here in the corner. You want it to be as close as possible to the things it's connecting. And RGPG in the chat room's right on the money, like, there's no heatsink on that. Yep, I pulled off the heatsink on mine so that I could show you this picture. But on my computer, when I'm running it, there's a heatsink right on top of that. Absolutely. I don't think this one came with a fan on the heatsink, but it absolutely had a heatsink on there. The question that Steve was asking in the room, because looking at this, there's two physical CPUs on this. Will they always have an advantage over a single CPU that's dual core? Well, yes, it will. A dual-core CPU still has input and output limitations to some degree. It certainly is not the same efficiency as having two separate CPUs. And although I don't talk about it in this month's study group, one of the new things on the Network Plus exam talks about virtualization. And I would expect, we're all expecting a new A+ certification requirements to come out sometime this year. We don't know when that is, but I certainly expect there will be a section on virtualization. I can't imagine there would not be at this point. It is a type of technology that has exploded. But the reason I mention that is that if I was going to build this as a virtual server, I need as much CPU as possible. I need as much memory as possible. I need as much disk space as possible. These virtual servers require tons of resources. When you're building a virtual machine, a virtual server like that that's going to store many, many different virtual environments, you're really starting to build these out with 128 gig of memory. Not the 4 gig that you have in your Windows machine. You start with 128 and you try to get more because you're going to use up all of that. Imagine running 20 or 30 or 50 or 100 Windows instances on a single piece of hardware. That's why you might need multiple CPUs. That's why you might need multiple memory. And that's why you need to know about these chipsets so you can start looking at those specifications and understanding, if I buy this machine for my virtualization environment and this machine for my virtualization environment, which one's faster? I see the specification for FSB, Frontside what? I don't know. But if you know exactly how it's working behind the scenes, you can understand, oh, the bus is this speed. It uses this speed of memory. Therefore, this machine is going to be more efficient for doing certain processes in our virtual environment. So very, very useful to have that and build that in. Now, if we were going to also look on this screen, we can see there are some slots in here. So those are those PCI slots. If we go back, I'm going to go back and look at the picture because we've already forgotten about it. PCI slots. There is Super I/O control. There is ROM, a flash ROM for our BIOS. There is onboard graphics controller, and the South Bridge has got to be in there too. So if we look at this picture, the next largest chip on this machine is right here, and that is indeed your South Bridge. You can also see there's some others here. Here's one from Adaptec. I know that if you start looking and researching this, you can go in and type in the exact numbers. You can't see the numbers very well on this screen. In fact, I'm just going to stop my slide right here and we'll just drill down into it. There's the Adaptec that's right there on that motherboard. And one of the things you'll notice about that Adaptec, If you go researching, that's a company that makes hard drive controllers. That's the onboard hard drive controller for what we're looking at. And if let me zoom out a little bit more. If we look at down further on this motherboard, let me move this down a bit. Ooh, it's really big, isn't it? Here is a ATI Rage XL, sort of an older chip. This is a little bit of an older motherboard. But you can see on there, I know it's kind of fuzzy, but ATI and Rage, that's your video controller. That's your chip that runs the built-in video that's on your computer. So some nice things to have available there as well. And right next to it, there's your BIOS. Yep. And look, Super I/O. It's even written right on the chip that that's a Super I/O chip. And because it's in the back of the computer, that's where all of the normal slots would be plugged in. So your serial ports and other things might be plugged in close to that, or they might be elsewhere. In fact, they're way over here. So that actually goes way over here, and the lines go all the way over to the other side. In that particular case, they made that engineering decision to put them on the other side, but generally it's slower type of input. You don't have to worry about it so much when it's running through there. Somebody was talking also, the crystal, the quartz crystal, the clock of the computer, isn't on there as well? Well, in fact, if we're going to scroll down again, right here, you'll notice there's this silver thing on here, and you really can't read it very well, but this fox is the crystal. It's the clock that is on your computer, and it has in it the counter. It's keeping track and counting and having cycles so that everything else in your computer can keep track as well. You have to have somebody keeping track and being the coordinating point for everything going on inside of your computer, and that is what that is. It's kind of nice to see that. It has the actual clock speed on it too. It doesn't have to be very fast. Everything is taking a multiple of that, or in this particular case, a fraction of that. So it can be a very slow counter, and everybody knows, well, I need to do 1,000 cycles every counter. I need to do 5,000 cycles every time that counter ticks. That's what that's all about. So you can find a lot of interesting things right out there in your motherboard if you start looking. And if you were to overlay exactly those pieces, there they are. And we just looked at them and we could figure it out. But your chipsets themselves are right there on the motherboard. You can lay them all out. You can look at them and grab your own motherboard. It's sometimes hard to see if you take the motherboard that's in your computer and you lift the cover off. It's hard to really look in there because there's hard drives and there's cables going everywhere and your power supply is in the way. But if you go online and you grab a picture of one, you can do exactly the same type of thing with much better resolution than what I was showing. You can really drill down and see all of those pieces in there. So the question is, and Steve asked this in the chat room, so I've got a CPU, it's got a big processor, it's a 3.1 gigahertz processor. Is that good for browsing? Is it good for gaming? Is it good for watching videos? All you know, based on the speed of the CPU, is how fast that CPU is going to process information once it gets inside the CPU. You know nothing else about the computer. If you've got a very small, very, very tiny front-side bus, so if you start comparing front-side buses, and here's a good test for you. Here's a good thing to look at. Go look at a front-side bus in a laptop and look at a front-side bus in a desktop. Put those side by side and look at them. And one thing that you'll start to notice is the laptops aren't quite as fast on their buses as your desktops are. And in fact, it's not just the front side bus, it's a lot of other things as well. Because a laptop, you have worries about heat. You have a small form factor. You can't cram as much in there as you can with a desktop computer. There's a lot of things you have to not do on a laptop because there's just not the engineering to be able to do it. Whereas a desktop, you got a lot more real estate. You got a lot more room to put a big fast bus in. You don't have to worry so much about the heat because you can put bigger fans in it to run through. And so now you can think of a bigger front side bus is going to get faster information from my memory directly into my CPU. That's going to help me for things like watching videos. You can see the type of video controller that's in your laptop will be different than the video controller you might have in a desktop because a desktop has these full-size PCI or PCI Express slots available to you. So these days you get a PCI Express video card, your fantastic video card for gaming. In your laptop, you can't plug in a PCI Express. There's nowhere to plug one in. It's too small. You have to take whatever that laptop comes with, and it's not upgradable. So you have to really look at the specifications, and almost always your laptop specifications are going to be much lower than the others. So that's why you need to know chipsets. That's why this layout and what everything is doing is so important to you, because every piece of this has an effect on the overall efficiency of the computer. And the more you know about how it works behind the scenes, the better off you're going to be able to understand exactly the type of computer that you would like to be able to see and be able to use from day to day. And that's one of those things that you always run into when you're working with these systems, is being able to make that happen. So that's an important piece of that. And then I appreciate the question that was brought in about chipsets. I think that was a nice overview for us to look at. So let's go to our next question from Tony. Thanks, Tony, for sending this in. And he asked, could you please give some exam-relevant examples of using the command line? Why, yes, I can. And this comes up from time to time. There was even a question earlier in the chat room, and I apologize for not getting your name in the chat room of what was there. There's a question about IP addresses and networking, and that's an important part of what you do in the A+ certification, is not only knowing the computer and the operating system side of things, you have to know networking and you have to know security. You have to know a lot. The A+ exam is probably one of the broad certification exams that you will ever take in your certification career, in your IT career, because it covers so many individual topics. And I always have to laugh when I'll meet somebody and go, oh, I could probably just study up right now. I don't even have to do very much. I'll just go sign up and take the exam. And you have no idea. You should go download the exam requirements documents. You should look at those and see what's there. Well, let's do this. Let's pop around on the screen. Let me get my screen ready for you. I've got a Windows here that we can look at. If I can remember what buttons to push on my screen to get to this view. Let's see if this works. Boom. There we go. I know it's really, really small up there on the screen, but I will make it so that we can see what's going on. I'm going to go to my command line, do a CMD, hit return, and now we've got something that we can work with. And let's room a zoom here. There we go. That looks a little bit better on the screen, doesn't it? Okay. So if we are at the command line and we're working on a computer for the first time, maybe somebody's come up to us and said, you know, I'm interested in knowing more about what's going on with this computer. So one of the things that you will be asked is, I'm having problems talking to the internet, or I would like to know why I'm having such a lag trying to communicate out to this server. Well, I need to know about the network connections. And there's so many things we can do here at the command line to do with this piece. So already the chat room's like, yeah, run this command, run that command. Rhonda over on the Professor Messer chat's like, do these. And I think I'm going to take Rhonda's advice here and do an IPconfig first thing. So A+ King in the other chat room said exactly the same thing. If you type IPconfig and you type it out, you will see on your screen, here it is the information about how this particular network connection is configured. And if you have a wireless card and an Ethernet card, you'll have multiple configurations to look at. Now, if we just look at the basic IPconfig screen here, you can see that it gives us our link local IPv6 address. And I talk about link local and other IPv6 things. I believe it's in my A+ certification. It might also be in a little more details into this. And in fact, RGPG was saying in the chat room, well, don't show your IP address. That's not a good idea. But actually, my IP address here doesn't help you very much. This is my local IP address that is inside. You'll notice it's a 192.168.1 address. These are private addresses that cannot route over the internet. If you tried to ping that right now, you would not ping me. There's no way that your routers out on the internet will send that traffic. They've already been programmed not to be able to route those particular IP addresses. They wouldn't route them even if you wanted them to. So that's good. And I also have on my network a number of 10 dot addresses as well. I have multiple networks that I run, as you can imagine, in my lab in my house. And these particular IP addresses, 1.22, is one that was assigned automatically via DHCP, Dynamic Host Configuration Protocol. I didn't have to type any of this in. I just started up my computer. In this case, it's a virtual machine. I started it up. It was on my local network. It talked out to my local DHCP server, which happens to be running inside of my Netgear wireless access point router, firewall, and multiple service device. And that device said, oh, you need an IP address? Here you go. Here's an IP address for you. And here's your subnet mask. And here's the default gateway you need to configure yourself for. And all of these things showed up. So I already know a lot about my computer based on this. I know this is my IP address, 1.22, 192.168, 1.22. I know my default gateway. So whenever this computer needs to talk out to the rest of the world, anywhere not on the subnet, it's going to go to that machine. Notice my computer here knows nothing of how to get to Google, has no idea how to get to CNN.com, has no idea how to get out to any website that's on the internet. So, but it doesn't have to. All it has to know is go to 192.168.1.1. It'll take it from there. And my wireless router that's out here that has that address of 192.168.1.1 has another set of routing tables inside of it that knows if anybody ever needs to go to the internet, send it out to the ISP, send it out to my cable provider, and they'll take it from there. Not every router in the world knows where every other router is. That would be a really big waste of resources. All you have to know is how to get to the next place, what we call the next hop. And as long as I know how to get to the next hop, I'm fine. I don't have to worry about all of the other things. I'll worry about what I need to know, which are all the things connected to me. And then everybody else, they go out to what we call a default route. Go out to the internet and do that piece. That's what that's about. So in fact, Steve in the chat room says, well, I got a 10 dot address, 10 dot something to something, something. Mine is 192.168. There are series of addresses that have big blocks of addresses that have been set aside for automatic, this local addressing that we can use. And usually they're provided to you automatically via DHCP. So you may see these automatic addresses, and there's an RFC that is specific to this. This is a little bit outside the scope of what you have to know for your A+ exam, but these blocks of addresses have been assigned for use internally. And 10.0.0.0, that big range of addresses, is one of those blocks. 192.168 is another range of addresses, and there's a 172 series as well. So depends on the environment you're in as to the type of addresses you're getting, but you will almost always, if you are an end user who is using a network and you are plugged in at school, you're plugged in at home, you're plugged in at work, you will almost always have a 192 address or a 10 dot address associated with that. Sometimes a 172, but not usually. The twos that most people are using is the 192.168. If you're at work, you're probably got a 10 dot address because that's a bigger block to use. So already we know a lot about this. If I wanted to confirm that gateway was one that was responding, it was working, I could use the ping command. I could send them a message saying, are you alive? Are you out there? And hopefully that machine will be responding back to me. So I'm gonna run that. I'm gonna go out here and let's run a ping. And I'm going to ping that 192.168.1.1. Very simple process to type that in and have it there. And by putting those two things in there, if I hit enter, it's now going to go out to that particular server, and it's going to respond to that ping. I pinged that address, and if that particular machine has now is now configured to respond to pings, because sometimes machines there are firewalled. If you try to ping a Windows machine, these days by default, it doesn't respond. A Windows 7 device will not return your ping because the firewall prevents anybody from pinging it. That way it's a little bit more invisible on the network. But by having this configured on my router internally, I can keep checking in with it. Hey, are you there? Let me ping you. It pinged it 4 times. It sent pinged it with 32 bytes of data inside of the packet itself as just a little self-check. And we got a reply back from 192.168 with 32 bytes. It is supposed to repeat back the same thing we sent it. It took less than a millisecond to get that return. And the time to live, which is a field inside of the IP packet that prevents loops inside of my network, is set to 64. So if this was to go through multiple hops, that number would be smaller. For instance. So if I ping 8.8.8.8, for instance, which is Google's DNS server, we get a little bit different on here. 8.8.8.8, I sent 32 bytes again. I got 32 bytes back. It took 35 milliseconds for me to go out and get a response back from Google. Because now I'm going back out on the internet and I'm streaming video here and I've got other types of links between me. I'm not locally connected. The time to live was 50. So already we know there are a number of hops between. And notice the time to live that I'm talking about is not the time of day to live. It's not the number of seconds to live. It's the total number of hops. It kind of has a bad name because we're talking about time. It's not really time. It's really hops to live. It's number of routers to go through before I die. That's a lot of numbers, a lot of letters to put in for an acronym. So we use time to live currently. That's what that's about. And that 8.8.8.8 was an external IP address. That is not one of the local IP addresses in my environment. That is the real IP address you go to talk to the Google DNS servers. And if you're going to configure a DNS server in your environment, you could use that, and you could do all your DNS queries out to Google if you wanted to. That's really useful to have there. Now, in my case, and Steve asked the question in the chat room, so does this mean I could only go through 64 different routers to get to where I need to go before these particular packets are just dropped on the floor? Yes, that's absolutely correct. So it's very unusual to have quite that many hops to go through to get to a particular location. Usually it's much smaller, but wouldn't it be interesting to see exactly what those hops were? If we were wanting to know more about what path does it take to go from where we are out to Google and back, because if I'm having a problem talking to Google, something's going wrong in between. Wouldn't it be nice to know where in between it is going? Well, yes, it would. So chat room, what should we run to be able to understand exactly the routes between me and, in this particular case, the provider and the Google DNS server that's providing me that? And Traceroute is a perfect example of this. Now, if you're in something like a Linux environment, you actually type out Traceroute. But in Windows, we don't do that. We use Traceroute. I realize this is not real time on the screen that you're seeing, but it's pretty good on my side. So I'll just keep adjusting the screen so you could do some of these things. And the parameter on Traceroute is we put in the IP address of what we would like to trace. Now, this is going to give us some pretty interesting results. Let's hit enter. Now what my computer does, it sends a series of ICMP packets, and it changes the time to live on these so I can understand just how far it gets each time. We're using that time to live packet to understand what's my first hop, what's my first route. Okay, what's my second route? What's my third route? What's my fourth route? Not every router out in the world will respond to these ICMP packets. And you may get to a particular server where it's not responding to these. And you may see it go through and just give me asterisks instead of showing me the actual piece that's there. So that's one of those things that you'll run into very often is the router won't respond. That's okay. We'll test it and then we'll go to the next one. So you may not get an actual result from that, but that's what that is all about. So if you run your Traceroute, you may get a different set of routes than I do. Now, this Traceroute by default is configured to route over a maximum of 30 hops. It will keep adding on that time to live up until 30, but we can adjust that if we want. But we didn't need to. Look how many hops we have. 13 hops between me and Google. And that's pretty common. Google is actually right there. Google is probably one of the closest servers that you will see because it is so present. It is right there on the core of the internet. It's very hard to get closer than that. And because I'm on Comcast, I go through first my local firewall that I have. I actually have a second one here that's on my, notice the 10 dot address. And now I've got other addresses out there on Comcast. These are public addresses. I don't mind showing these because these are Comcast routers that are out in the world. These are not secrets. It's not something I am worried about telling anyone because there are many other people in this environment able to use that. You could ping that address from where you are and see if that particular router that I'm using to get to the internet is even there. So it's very nice to have that available and to be able to see those pieces of it. And I hop through these Tallahassee, the North Gulf. It looks like here's Georgia, Marietta, Georgia is where that packet went. And then it went to these IP addresses. There's no names on them. Notice it didn't give me a name for those particular IP addresses. That's probably because the provider for those particular routers did not put a name in the DNS entries. And that may be just a way to obfuscate the name. Maybe they didn't want you to know where it was. When I look at this particular device, the 68.6.95.5, it's in Marietta, Georgia. So that's one of the things to think about, that maybe all of these routers, you won't know exactly where they are, but you knew exactly the path that all of your packets went through to get to Google and then back to you again. Yep, you can absolutely ping that particular router. It will work. Told you. We have people, oh, really? Can I do that? Yep, RGPG pinged it, and sure enough, worked just fine. So that's what I would do. I would probably document these. And so now I know when it's working, here's what it looks like. Now, if I suddenly am not able to get to Google, I could do a trace route to Google, and it will step through this trace route, and at the point where it stops is where I know perhaps a router is broken. So Traceroute can be a really, really useful troubleshooting tool for you if suddenly somewhere in between you're having a problem. Let's say you can't get to Google. You call your provider and they say, I'll have you turn your computer off and back on again. Well, I don't think that's my problem. But you can't prove it to them. You can't prove that you've at least got connectivity to a certain route. But if you do Traceroute, now you can tell them, well, actually, I've been assigned an IP address and I perform a traceroute and I can clearly get through your router on 68.87.161.101. But I've noticed that when it tries to get to what normally is the Gulf Coast router, that router is not responding to me. Then they know immediately, well, the problem's not at your house or your work. They know the problem is now not even in your neighborhood. It's not even in your city. So they don't have to worry about the configuration of your computer. They don't have to worry about the configuration of the wiring that happens to be outside of your home. They know immediately, oh, you're right. We've got a bigger problem, and it's with that particular router at that particular facility. So this can be incredibly valuable, very, very short time frame to start troubleshooting some of these things. When I first plugged in my home cable modem many years ago, I was one of the first people in my particular part of the world to get that cable modem. I was on it. Yes, plug it in immediately. Give me one. I was running ISDN. I want that cable modem. They plugged it in. And at that time, they gave you an IP address. You had to manually configure your IP addresses. And I did, and it didn't work. And I did Traceroute, and it didn't get farther than my IP address. But what I did was did some packet captures out on there and saw I was on a different subnet. And I said, well, I'm seeing traffic coming from you. So we don't have a problem with the wiring. This Traceroute can give you a similar example and say, well, I know the problem is that I'm seeing data. I can talk to you to a certain point, but now I know the problem happens to be outside and where it happens to be. So very, very useful to have that there and use those pieces of it. So as you're doing some of these things and working at the command line, you don't get the same type of detail when you're working inside the Windows environment. There are some third-party apps you can get that can do similar things to this, but it's not built into Windows. So this command line can be very, very useful to do things about that. So let's look at some other things that are there. And yes, A+ King, I can see but I'm not going to puppet things they tell me in the chat room. We're going to keep things probably on the up and up over here, and we'll keep going with the content that we have. Belinda asked in the chat room, can you make a user account on the command line? You absolutely can make a user account on the command line, and it works exceptionally well to be able to do that. If you look at, I have a course for the 7680 Microsoft exam, which is using Windows 7 and configuring Windows 7. It's really for the administration of Windows 7, way beyond the requirements for A+. That particular exam is one that has a lot of command line things that you can do for adding users and removing users and modifying their rights, all at the command line. You can do a lot of things to be able to use that command line to its utmost capability. And there's even scripting, PowerScript, and other things you can do at the command line to be able to take advantage of that as well. Let's get back to some of the other questions that we had. I'm already running way behind. I've got so much content in this particular users group that I'm probably going to run out of time before I get through all of those. We'll try to get through as many as we can. So one of the things that, now that we've talked a little bit about the command line, let's talk a little bit about networking. Both on the 227.01 and the 227.02, there's a big section on networking. And part of that networking section talks about SSIDs. And so Jasmine asks, what is this SSID thing? What is that all about? And why would we use them? Why do we even have to name a wireless network? Let's just connect. Just do it. Why do I have to put names in for things? Why is that really important to me? And what we have to do is really understand how these wireless access points work to begin with and get a feeling for this. Now, this is from a screenshot I took from just a little utility called KissMac on my operating system. There's others that you can use like on the Windows environment to look at wireless networks, the network stumblers and the wireless stumblers and the wireless network analysis tools. You can get the SSID in many different ways. But what this shows you, you'll notice, is an SSID and a BSSID. There's two things listed here. What this utility does is it searches around to be able to find things that are out there. Let's make this a little bigger. I know some of you out there on these tiny little screens on these streams, so it'd be nice to blow some of this up and let you see it. So here is the KissMac screen that shows me a little bit about this, and you can see one of the first things it has found, it's found 4 different access points, and each one of them has a different SSID. There is this one, WATPOPWUAN. Here's one called Netgear. Here's one called S Network. Here's one called Linksys. So you've got a little different. Some of these are the defaults, the Linksys, the Netgears, and you'll notice there's also a BSSID. That's definitely not a name we would recognize. Nobody typed those in. This BSSID is the physical address of that particular access point. It's like a MAC address might be. It is working at the DLC layer, the layer 2 of your OSI model is your physical address of a device. That's the physical address. So us humans connect to the access points based on name. Oh, I want to connect to Netgear. I want to connect to S Network and connect to it. Behind the scenes, your computer figures out, oh, you really need to connect to, behind the scenes, I'll send your packets to A021B763403E. or whatever it happens to be. And those are in hexadecimal format, separated out with those colons in between. So now we can see, we know how users access the SSID. We know behind the scenes, the network uses the BSSID to be able to do that. Some of these are secure. You can see some are encrypted with WPA2. Some are wide open. I should probably call my neighbors and say, you might want to put a password on that. You might want to encrypt your data. Probably a good idea, because I'm getting a pretty good signal out of these. I could probably connect to the Netgear one from where I'm sitting right here. And you can see I did that last year. So a lot there. The SSID, as I mentioned, your service set identification, uniquely identifying the network. And the reason we put a name on it is we might want to put multiple access points in a single place. One for the marketing team, one for the accounting team, one for guests. You can separate things out that way so you can configure your computer to connect to the access point that's appropriate for what you're trying to do. That's why we have the names assigned to that. The BSSID, as I mentioned, is that MAC address. You as the end user, you as the administrator rarely uses that. If you were looking at a packet capture and you were trying to make sense of what you were seeing in all of those packets, that might be very useful for you at that point. But you don't need to know the BSSID for configuring Windows, for configuring your access points, for setting up really anything. It's really, really useful for you to be able to use that from a troubleshooting perspective, but not really anything else that you might need on the BSSID side. So A Plus King asks, should we put a random name or a name that means something to you? It really doesn't matter exactly what you name the SSID, and you may want to make it as recognizable as possible. You might want it to say professor. And if it says professor, people will know, oh, that's yours. I know that's your access point right there. Or you might want to make it like this one on here, WATPOPWUAN. I look at that and I don't know. It's not a last name of anybody. It's not even a street name. I don't know what that is. Somebody made up that name and put it on an access point so that people would not necessarily know where that access point happens to be just by looking at the name. Now, obviously, I could get a strength meter. I can even carry my laptop around and figure out the strongest source of that signal and kind of figure out physically where it is that way. But just by looking at this list, don't know what it is. You might want to make it easy to remember, because you can tell people, oh, you need to connect to the guest one network. You need to connect to the S network to be able to connect to my network. So it does become very useful to use something that you can at least remember and tell other people. It is not a security method, and even disabling your broadcast is not anything relating to security, because you don't have to tell people. You don't have to have your access point configured to broadcast out the name of your access point. And that's one of the things that people think, I'll just turn that broadcast off and now nobody knows I'm here. Nope. The only thing you've done is not broadcast it. And it also becomes very easy to find that through packet captures. It's in no way anything related to security. It looks invisible, so people won't accidentally connect to it and click on it. But anytime somebody connects to your access point, that is sent out. And if you have something like the tool I was using, it'll see it immediately and pop it up on your screen. Very, very easy. It's also important to consider that there are many programs that can fake being an access point. Oh, it says access point X. I'll connect to that one. In reality, it's somebody running access point software on their computer. And even if they encrypt the data, they're decrypting it on their computer, and they're able to see everything going through. So make sure you only connect to access points that you know what those are. Oh, this is the one at Panera Bread. This is the one at my house. This is the one at my work. This is the one at Starbucks. And I know those happen to be the access points. They're listed at the front counter to connect to our access point, connect to this SSID. And that's what that's for. Now, another question that came up in the chat room, where was it? Question was, so is the SSID the name of each individual access point or the name of your wireless network? Oh, so that's a pretty good question, because in my house, I have two access points. I have one on one side of the house, and then I literally ran an Ethernet cable in my attic to connect another access point directly that's in another part of my house. Now, I realized I didn't have to run the cable. I could have done a repeater to do that, but that's a different conversation for a different time. This is where I did it on mine. I named those the same wireless name. And the reason I did that is I want to be able to walk from this side of the house to the other side of the house and seamlessly connect to whatever's closest to me without being prompted on the screen on my mobile devices that now I'm connected to a different access point. Because it's the same SSID with exactly the same configuration for encryption, it seamlessly hands it off from one to the other. And I've got one set on channel 1. I've got one set on channel 11, so there's not going to be a conflict with frequencies either. So it makes it very easy. By setting them both the same name, it's the same network. And therefore, it can then communicate and work perfectly to be able to do that. A Plus King says, why not use home plugs where you plug into the power in your house and you plug in wireless connections to that? The throughput of that is certainly questionable. And what we found over time is somebody who has an amateur radio license, those tend to put out a lot of noise on the amateur radio frequencies, which is a bad thing in Florida. In Florida, we like to have our amateur radio frequencies working very well because we tend to get hurricanes. We tend to get natural disasters. And when there's a natural disaster, your mobile phone isn't going to work, your home phone isn't going to work, your cable voice over IP phone isn't going to work, but your amateur radio connection will absolutely work. And by minimizing the amount of interference that is on those amateur radio bands, we also are able to do our tests and our drills and be ready for the problems when they happen because our amateur radio frequencies are perfectly clean. And unfortunately, home plugs are kind of dirty when it comes to noise on those amateur radio bands. They aren't that great. So I don't use them just because I don't think they're useful for me to use. I need a lot of throughput. And at the end of the day, I think they may also be harmful to the things that are doing with our amateur radio frequencies. So that's a little bit of an aside for the study group, I realize. But that's it. I'm AG4DX Alpha Golf 4 Delta X-Ray for those of you in the chat rooms who are also amateur radio operators. So the study group, by the way, another great sponsor of our study group are the folks at GTS Learning. I was in London in November speaking at a conference and had an opportunity to spend some time with the folks at GTS Learning. Their headquarters is there in London. And these guys make training materials for a lot of different things. They focus a lot on CompTIA. And they have CompTIA A+, they have Network+, they have Security+. They're doing some really, really innovative things with study guides. They're doing really innovative things with providing details, this type of content to you in detail over the internet. The whole medium, what we're doing with electronic communication has changed the way we study. It's changed the way we learn. And the folks at GTS Learning are right there on the very edge of that. They have some great study materials for A+ as well. And you'll notice if you go to freeaplus.com, it takes you right to my list of videos. You can go through all my videos and watch them. Right at the top of the page, I put their book right there because I've sat with them. I've gone through their materials. I've looked at their books. Their books are one of the few that I've ever seen that are actually authorized by CompTIA. There's right on the front of it is they've been approved. It is official courseware from CompTIA. CompTIA said, I've looked at this and everything in this book is exactly what you need to know to pass the exams. And I really like that about that. I was very impressed with what they were providing from a training and learning perspective. In fact, I've now started integrating my videos directly into their books. If you see their Security Plus book, you'll notice the Professor Messer videos are right inside of it. So if you read a section on security on wireless encryption, there's a link right there that you can click on and it pops up in my wireless encryption video. Or if you're on a mobile device, there's a QR code. You put your mobile phone in front of it and take the picture, and now it starts playing on your mobile device. Pretty nifty. We're going to do that for all the books. It's just another way to get that information to you. And suddenly, the book and the video are one thing. and you just study everything as you go. You don't have to keep searching around for everything. Really good books, a lot of great information here. If you're looking for an A-plus book, I highly recommend you look at these. You can go out to professormesser.com/A+book, and you can even download a sample and see for yourself. Don't take my word for it. That sample will show you exactly the way books is laid out, has content in there that you can look at, and you can make the determination. They've also got some other great things on there for virtual study guides. You can set up a virtual lab on your screen and start plugging in different devices. And it's all right there, professormesser.com/A+book. And we thank GTS Learning for sponsoring these study groups and many other things that you see us do at Professor Messer. Let's go through some of the questions. I realize, by the way, that we're kind of like at the very top of the hour. Usually I like these to go an hour, but I talk a lot. So it's a little bit more than an hour. And the great thing is we're live on this stream. We don't have any particular time frame we have to worry about. So I'm going to just keep going with the questions that I have. We'll go through a few more of these. So this question that I have is relating to everything at this point. It's relating to taking the exam and understanding more about what's on the exam. After taking practice A+ tests, I find that there are questions based on experience, such as the ribbon size for a floppy drive. This comes from Galen. There are questions I get all the time, things like, what IRQs do I need to memorize? Because I was taking a practice exam, and it asked me a bunch of different IRQs. Or it asked me, after taking the practice, I took a practice test, and it asked me about the size of the floppy drive ribbon. How many computers these days are even shipping with floppy drives in them? No, not very many. How many computers do you even have to worry about configuring the IRQs in? None. It's all plug and play these days. It's all done automatically. It's important that you know about floppy drives. It's important that you know what the IRQs do inside of a computer, but it's not necessary these days to understand the exact IRQ and what it means. An IRQ4 is your serial port COM1. You don't have to memorize those. It's not a requirement on the CompTIA document. It, in the past, was a requirement for your CompTIA A+. It was on the exam requirements document. Those are some old exams that you're looking at on the internet. And that's one of the disadvantages of these exams that you get on the internet is occasionally, actually more than occasionally it seems, the material itself is way off what you need to know to pass your exam. So don't worry so much about the details of those. You're not going to need to know and memorize IRQs, but you will need to know what they are. So keep that in mind. Get your sample exams from a reputable source. GTS Learning has great sample exams. There are other big names in the industry that have great sample exams. Exams that you find on the internet are, in my experience, have almost always been out of date, and the ones that aren't, unfortunately, have a number of mistakes in them. And you actually find yourself, wait, I know, that's right. I looked at that. That's absolutely correct. I didn't get that one wrong. Actually, you're in great shape. If you can do that, you're probably ready to take your exam because you know more about what you're trying to learn than this exam was trying to teach you. So very, very hard when you get to those practice tests to have to deal with those kinds of things. You don't have to know the size, how many pins are inside of a ribbon cable that connects to your floppy drive. Not important for you, and even less important going forward. It's important to know that it is a special floppy drive cable. It is not the same cable you use to plug into your hard drives. There's not much more you need to know about that piece. Another question from Mary Claire was, why do most employers consider having a certification more important than having a degree in IT? You would think it would be different. You would think a degree would have a much more powerful standing in it than having a certification. Now, the reality in this is it sometimes certainly feels this way. It certainly feels that we're not even able to talk to anybody about the job because all they want to know is, do you have a certification? Do you have your A+? If you don't have your A+, we won't talk to you. And that's very disappointing sometimes when you have a 4-year degree in business or IT or anything else that's associated with that. It obviously took you a lot more time to get your degree than it did to get your certification. But it's not one or the other. And it's not that one has more priority than the other. Certainly, if somebody is only looking at certifications and not looking at anything else, that's probably an employer that is very short-sighted. But they often use certifications as a method to at least initially qualify you to be able to come in and have a conversation and have an interview. All of these things work together. along with your experience. If you even have experience to go along with the certification after you've gone through a 4-year or 2-year degree or any type of study, formal study that has taken a series of time and you've gotten a degree, that's very powerful. So you often have to have the certification to get in the door. But at that point, you're on a level playing field with everyone else. Everybody they talk to has got the certification. What good? Now what good is the cert? The cert got me in the door, and now it doesn't get me any further. But now everything else does. I can tell you that I do have a degree in IT. Thanks for inviting me in. I have a degree from this organization, from this university, from this college. We studied this. I did one of my big projects on connecting wireless networks across large distances or whatever it happened to be. Be able to provide those experiences. If you also have experience, and while I was in college, I worked part-time for this computer company. Well, we repaired motherboards. I replaced chips. I did this particular piece of the hard drive configuration. I set up our Active Domain directory. All the things you do now build and work together. So it may seem sometimes that, wow, I've got a degree that I've spent 4 years and a lot of money and time and effort and sweat and blood to get this degree, and now nobody will talk to me. Don't worry about that piece. Just think about how important it's going to be to get your certification so that you can get in the door, and then it's up to you. You've got to be able to communicate. You've got to be able to talk about your experiences. You've got to have something to talk about. All of those things are going to work together for you. So don't be dismayed that somebody perhaps is not paying you any attention because of your degree. I think every piece of this counts, and they count in different ways. And we have to make sure if we're planning to start a career or to continue a career in IT, that we work on every single part of that. You can't just work on certifications and expect to get a great job. You can't just work on your degree and expect to get what you want. You can't just have experience. You need to have all three and perhaps even more things working for you. And talk about, oh yeah, I have a lab at home, and here's what I do on my lab, and here's what I've studied on this, and here's the pieces that we've done. I've built a website, and we've connected them together, and I'm running MySQL, and we're working with Linux, and all of these things help in an interview. You know, there's no formal experience there for something you did in your lab, but it's incredibly useful to tell someone when you're sitting in front of them in an interview. So that's one of the things that I think about when I have interviewed people in these positions, because I've been in director roles where I've had to hire a network team, and I've had to hire somebody to work on firewalls. I've had to do all of that. And it becomes very important for me to understand what they think about when they think about technology and what they've done. And just because you don't have any formal Linux experience, somebody may not have paid you to work on a Linux machine, but you have an amazing amount of experience in Linux doing your own things. Those are useful things to know. So consider your certifications, consider your formal training, consider the things that you also do along that's outside of both of those particular scopes. And I think that'd be very, very powerful for you when you start looking for those jobs. A question in the chat room was, can you get a job with only certifications and no formal IT school degree? Well, absolutely. But you are going to be in a disadvantage of other people who might be in the running for that job that do have a formal IT degree. And that's where it really helps to network. If you have a local users group of any type of technology, if there's a Cisco users group almost everywhere these days, you might want to consider being a member of that. If there is a VMware users group, there's tons of those everywhere. You might want to be a member of that. And there are also other types of user groups that are general technology user groups. You may want to become members of that. The more people you know, the better off it's going to be. You may walk into an interview and go, oh, I just saw you the other night at the users group meeting. Already you've got a connection there, and you can take advantage of some of those things. And the point in the chat room is there are different things that you run into where in an interview, you may be asked certain questions. They may need a person with a particular skill set. I was just reading today, and I forget it was the Wall Street Journal, but I Instapapered it. I'll have to bring that up later. That says the number of people who know Linux is very, very low. It's very hard to find somebody now to do Linux administration because all the big businesses have suddenly realized we can do some neat stuff in Linux. Yes, Windows is continuing to be our primary operating systems, but we're increasingly putting more and more and more things on a Linux platform, and now we're starting to see the demand creep up. You will be able to get a Linux job easier because there's not a lot of competition, because there's now a lot of need for it, and now people aren't worried so much about Did you get a Linux certification? I don't care. I just need this website to work. That kind of thing. So there are places where you can push aside some of these things. That's certainly not the norm. You certainly need to be well-rounded to be able to do some of those things. So it makes perfect sense. And during the week, I don't hire people. So the question in the chat room from A Plus King, what do I do during the week? I do have a full-time job. I do things where I'm traveling, I'm talking to companies, I'm doing things and moving around a lot during the week. So I do get a chance to see a lot of these organizations, large companies, small companies. I get to see how they're structured. I get to see what they're doing. I get to understand the types of challenges they have with applications and security and the systems that they're running. And there's a need out there for smart, well-rounded, educated people in technology. Even the people you think that are hiring you think that they're all top-notch, number one, 100%. There's a range of skills. Everybody has different kinds of skills. You may fit perfectly into filling some holes they might have in their organization. And these days, people are desperate to get the right kind of people. And if you just get a foot in the door, you can go anywhere with this type of thing. So our next question. Alex asked via our Facebook, because earlier this week I said, okay, Facebook guys, I've got very, very fortunate to have about 12,000 people following us on Facebook. You can also follow me on Facebook at professormesser.com/Facebook. And I think I even now have the facebook.com/professormesser now. So you'll be able to get there either way. So I asked those guys out there, what questions do you have? And Alex said it's 2012, technology going like crazy, going the moon. So should I be learning voice over IP? Should I be going cloud computing, mobile technology, virtualization? These are the buzzwords. If you were to look at the IT websites that are giving you the news, go to Network World and you read Network World. That's all the buzzwords you seem to hear. Is nobody just doing web pages anymore? What happened to the core technologies we were working on? We got voice over IP, cloud computing, virtualization through the roof. There is tons of things going on with virtualization out there. And that's one of the things you have to think about is, do I have some skills that I can bring to the table that are new and different? Because I can tell you that organizations out there don't have all of these things filled in very well. There's places where they need assistance. Voice over IP is incredibly complex, very, very complex environment to work in, very diverse, extremely different. If you know Avaya voice over IP, you know that it is incredibly different than Cisco voice over IP. So just knowing voice over IP isn't even good enough. I need to know a flavor of voice over IP. Then you need to know how to do web conferencing, video conferencing over voice over IP, high definition video conferencing over those IP protocols. How does that work? With whose technology? How do you integrate it? How do you secure it? How do you maintain it? Those are very, very important things to consider. Voice over IP, incredibly useful skills to know. Anything that's new, anything that is something where it is a technology that is just getting started or is just now hitting a major piece like cloud computing, mobile technologies, virtualization, that's a great thing to study. The more you know about it, the better off you're going to be. And if you think of anything in technology, think about database management. Cloud computing, very important. Mobile, very important. The virtualization, incredibly important. It affects that. Well, let's look at web servers. All of those things I just mentioned also have a huge impact on web servers. And that's why these technologies have become so important to the forefront, is because they touch so many parts of what we do in technology that you're going to need to know these things to be able to keep up just with what you're doing. And that's one of the great things I love about this industry is no matter what you're doing, you're going to be reading more and more. You have to keep up with what's going on. Otherwise, you're never going to be able to move forward in what we do with these things that we work on. So the question in the chat room, in fact, talking about this cloud computing and types of things, this was, is it safe to use software like Dropbox where your things are in the cloud? Well, I guess safe would be a relative word. It depends on what you're doing in the cloud. Is it safe? No. No, it's not safe that it's digital, much less in the cloud. Safe is a relative term, I guess. If I'm counting on Dropbox to always be there and to always have my data available to me, then probably I'm not thinking about this very well because I can't guarantee that. It's free, so there's certainly no inherent expectation there that it will always be available to me. And if I put something out there, there have been times from Google, from Dropbox and from other organizations that store your data in a place that you thought was private, where they've had to come out and say, well, you know how we told you that nobody could get to your data? We kind of had this thing where people could get to your data for a day or two. It has happened in the past, remarkably. And of course, they found the problem, they turned it off, and now it's private again. So if security is what I think about, and I think privacy equals security, that wasn't very secure. And if you look at what happened to organizations that you thought might be around, Mega Upload was clearly doing illegal things. They were taken down not for so much the copyright piece, but the racketeering. And there were people using Mega Upload for perfectly legitimate reasons. But that's too bad, because the whole company's now gone. These guys are in jail. You know, who knows where your data is going to end up at this point. So there again, if security equals knowing where my data is and having it always available to me, that's not very secure either. So what am I going to do? That's things you have to think about when working in cloud environments. That's why in the latest Security Plus and Network Plus, there was huge sections about cloud computing and virtualization. I certainly expect in the next iteration of A+, those technologies will absolutely show up there as well. And that's one of the important parts about keeping track of what's going on and having the latest certifications and knowing these technologies, is that they're going to affect you in some way. And that's one of the challenges we always worry about when dealing with those types of technologies around the world. The questions from the chat room, there were a few miscellaneous questions that have come up. I'm going to scroll back just a little bit on there. You know, the term, in fact, the mention in the chat room, you have to trust Dropbox with your data in a cloud environment. Well, that's incredibly a valid point in making sure your things are there. Who do you even know is running the company? You just know that it's free. You can stick it there. What are they going to do with it? Are they going to count up what the data is? Are they going to count how many? Are they going to use me for marketing? Or are they going to say, well, we have this many people storing spreadsheets, and that means that you should store your spreadsheet as well, and we have a service for that, and you can pay us. They might use your data to help them further their efforts. Almost every end user license agreement and terms of service that you see has some aspect on that as well. The hospital IT guy even mentioned also in the chat room, going back to our conversation about, do I need a degree? Do I need experience? Do I need certifications? And he had 12 years of experience, some studies, no certifications, no degree, but because he had worked so long in the industry, 12 years, and knew people in the industry, made these relationships and understood what was out there, it became easier for him to get a job in IT based on who he knew and what they needed at the particular time. His skills fit perfectly. A great example of what I mentioned. You know, it doesn't necessarily have to be one thing or the other, but it helps if you have everything. In his case, he was able to rely on those years of experience. And sometimes that's all you got. Use it the best you can. Absolutely. There is one of those things that we look at in the chat rooms. One of the questions that came up is about the cloud computing, the ports that are available, those types of things. If you're blocking certain ports, can you get to access certain pieces? Remember that these port numbers, there's a whole section on the A+ certification exam on knowing the common port numbers. And so you have to know port 80 is HTTP, and that's the protocol that we use to talk to a web server. So on my computer, do I now have to unblock port 80? No. The port 80 that we're using is on the server. These are server port numbers. If you were running a web server, you would have to make sure your firewall allowed port 80 to your web server. You're using a completely different port on your computer to talk to that web server. You don't have to unblock anything. The web server is the one that has to open those doors for you to allow that traffic in. Pretty important on that piece there. The A+ King asked in the chat room about storing emails in the cloud. There are an increasing number of services that are providing these services in the cloud. There is URL filtering in the cloud. There's email spam filtering in the cloud. There's virus checking and control in the cloud. There is storage of your data in the cloud. And in a way, you might even consider the Professor Messer website. That is a hardware service that is provided to me. I provide the software, but the hardware is in the cloud. I don't care where the hardware is. Doesn't matter to me. It's not in my house. It's just somewhere. I can connect to it to my web browser. I can connect to it through a command line and do the management of the device. They could put it in, in China. They could put it in Kansas. They can put it anywhere they want. I don't care, as long as it's available to me and the speeds are what I need for people to access that data. So in a way, cloud type services can be extremely valuable, very cost effective. It's certainly provided all of you with uptime to my website, and I've not had to worry about any of that locally. So you have to measure how you work with that. Now, in my case, Professor Messer is locked down. Nobody has access to it but me and people that I have trusted to be able to handle certain services on that server. But that's it. The people that handle the hardware don't have access to the server itself. So it's one of those things that I have sort of a mix. I have a blending of that cloud computing, if you want to look at it that way, with those pieces of it. So it becomes very, very useful to do that. That's one of the important things about considering that and where you're going with those pieces. The question that Brittany asked on the Professor Messer chat was one where we're opening these ports, we're allowing this traffic through. Now, the hackers also are looking for those open ports. So is something like virtual operating systems then something that can help us be more secure with these pieces? Now, as many of you know, I also wrote a book on Nmap, which is a security tool that's used to find open ports. And it's used by legitimate people to secure their networks. It's unfortunately learned by people who may not be using it for legitimate purposes. So you do run into those situations as well. The question with virtualization, though, doesn't really help very much from a security perspective, because even though you've taken a physical device, a physical web server with open ports, and you've now moved it into a virtual web server, the port's still open. Ports are still there. In fact, in some ways, it's even less secure than the machine that was sitting by itself alone. And here's what the hackers are trying to do. When you put something into a virtual environment, you have perhaps on a single physical piece of iron, a single physical computer, you might have 20 servers running on that box, 20 virtual servers all chopped up inside of that machine. Now, the hackers realize if I can get access to one of those virtual machines, and I can somehow break out of that virtual machine and get into what they call the hypervisor, or the overall manager of all of those virtual devices, I could theoretically then gain access to all of the servers. So obviously, this is a huge concern in security. And that's why there's so much time and so much effort spent on securing the hypervisor, because there have been situations in the past with certain virtual machine managers or hypervisors where we have taken that hypervisor and have broken into it from a virtual machine. Now, that was in the lab. It was not something that people were able to exploit, and it was something that was fixed very quickly by the company making that. But boy, think of the implications. Think of from a security perspective what that means. So the security overall is changing. We are moving from one that is port-based to one that is application-based, and that's one that's really going to help stop the hackers from a port-level perspective. We are also in a position where we have to now do more as traffic's going by. If I could scan for viruses as it's going by, if I could have smarter vulnerability protection and IPS, it just makes sense to be able to do that. Having that piece available becomes a really, really important, and something to consider when you start to see on the A+ exam, there's network, there is security, it all works together. And everybody has to keep track of the networking piece, and these days everybody has to keep track of the security piece as well. Well, it looks like we have run out of the miscellaneous questions on the chat rooms. We've gone through a few of those. Oh, one more that was asked, by the way. I saw this one, which was RGPG makes a good point about, should you really care where the equipment is, though? Because he makes the point that in California, there could be earthquakes. If you were in Florida, there could be hurricanes. And in fact, that's a perfectly valid point. I would want to have my hardware somewhere that's safe. In the case of virtualization, many people will have a server spun up in one data center. And if that particular virtual machine gets busy, or an earthquake hits, or there's a hurricane coming, they can click one button and suddenly that virtual machine spins up on a completely different physical server in a different state, in a different geographical location. This is done all the time. Maybe it's getting very busy. Now, suddenly my machine moves halfway across the country and spins up on a bigger machine, and nobody even knows. Suddenly, I'm on a bigger, faster machine. It's got more bandwidth. It's got more hardware capabilities. It moved to a different part of the world and nobody knew it. That's the power of virtualization right there. Very, very good stuff. Very, very powerful stuff. So one of the questions also from A+ King when you're dealing with wherever it is in the cloud is the data protection laws around the world are very different. And that is a bit of a challenge. One of the things that you find if you go to Germany is that the people, if you're working in a company, the people administering the network or the security of that company do not have the right to look at your data and your communication from your machine. Now, that's very different in the United States. In the United States, in the United Kingdom, if I'm managing my network, you're at work, and you're on my computers, I have absolutely rights to see everything you're doing. I can listen to your phone calls. I can read your emails. It is legal for me to do that. Hardly anybody does because it's boring. And if it's a high security environment, if it's like a top secret, of course they do things like that. They lock a lot of things down. But for the most part, they just don't want you to go to sites you're going to damage your machine by downloading malware. We try to protect you from wasting too much time at work, but generally people are pretty open about these things. But in Germany, oh no. You have to build all of your hardware, your equipment, your networking, your visibility products so that you can turn off people's names. So you can turn off or obfuscate their IP address so you don't see their IPs as they're coming through. Very, very interesting at being able to see that. Very, very important consideration around the world, especially if you're building a company here. How do you handle data that's coming from Germany? It's one of those things that makes it a little bit different. And the laws are changing around us all the time. There are entire groups of people that do nothing but handle these legal challenges that come up associated with technology and associated with these global networks that we have. A+ King says, why do people make adware? What's up with that? Because there's money to be made there. That's why they make adwares, because if they show you ads, they get money. Done. If they can sneak your machine into popping up messages that are going to show you ads, they're going to make some cash. And if they can pretend that they're going to click here to see a funny video. I love funny videos. I click. That wasn't a funny video, but now you've clicked and now the malware is on your computer that's showing you ads. And now the person who managed to get that malware on your computer is making money from that. Very, very painful. Very, very difficult. That's why it's becoming so important these days to be able to find these as they're happening, and they're changing all the time. We're coming up with new technologies all the time to be able to identify unknown malware and stop it before it gets on your machine. So quite a challenge in being able to do that out there. Some announcements. If you need to see me, find me on Facebook. You can find me, if I can get rid of my big head there on the screen, you can find me at professormesser.com/Facebook. On Twitter, I can be found at professormesser.com/Twitter. Google+, professormesser.com/Google+. Do we see a trend here? And just before I did the presentation today, I made a professormesser.com/YouTube. So you can go to YouTube very, very easily from that. Again, I want to thank GTS Learning for their sponsorship of the monthly study groups. We'll continue to do these study groups. They're very, very good feedback that I'm getting from you. And through the month, as you have questions, send them to me. And I hope to get them in our next one. Our next study group is not January 14th, since we're on February. You can tell I did a lot here on the last slide, is March. And we're in March. Who knows? Put a question mark right there. So when is it going to be? It'll be in March. We do one once a month. I recommend what you do then is go out to professormesser.com/calendar and look at our calendar. I'm going to update it and make sure that everybody knows when that's going to be. You can also, if you've signed up for our study groups, there are links on the calendar to sign up to the mailing list. I also send reminders out via the mailing list. Follow me on Twitter. I send out tweets about it. Follow me on Facebook. I let everybody know. So I try to let everybody know what's going on with those pieces. I want to thank everybody for coming to our A+ study group. The feedback in the chat rooms was phenomenal this month. Your questions that came in were great. I had so many. I didn't even have time. We went 30 minutes over time this month. So it's one of those things that we've got plenty of material now. I can come back next month with those and, of course, all your new questions that we're going to do for the study groups. Thanks, everyone, for attending, and we'll see you next month on the Professor Messer A+ Study Group.